Hi guys, today's lecture for modeling the girts and purlins, the purlins for the roof frame and the girts for the wall frame. We will use the tool of beam system to insert dies. It's a very useful tool that will allow us to adjust all the specification of a group of beams in terms of the spacing, the size, the section will be used, all of those specifications that we'll need for a group of beams altogether, rather than inserting each beam separately. In order to do that, first of all, we have to check if we have the sections for the Australian standard or Australian manufacturers for cold form sections or C sections, C or Z sections, lightweight steel. If we go to insert load families to check what we've got here under the Australian groups of families, if we go to structural framing and light gauge steel, we find a group of sections that we've got there. The first section that may be used is the lip channels, light gauge lip channels. The problem with this one, if you open it, first of all, the sizes are not very consistent with what we use here in Australia. I'll show you the sizes that we use here in Australia from Lysat, is the main manufacturer from Blue Sky here in Australia. So we have a larger variety of sections and thicknesses comparing to what we can see on the light gauge lip channel. So that's not going to be appropriate to be used a lot. Doesn't give us too much variations. That's one. Two, the accuracy of these measurements for the section depth, width, thicknesses are not consistent. Secondly, the second section we may use is the joists. The naming convention on these joists is a little bit better, closer to what we've got into the Australian Lysat selection or group of sections. The problem with this section here, from experience, when you use or insert one of these sections into your model, you can't create connections to this section for some reason. So when we started looking at the purlins, cleat plates and connection to the rafters, we couldn't insert those. That's why I've created a small family. We'll cover these sections we've got from Lysat and uploaded this family to your Learn page under Beam Systems. If you click on this tutorial 6, Beam Systems for Purlins and Girts, you'll find Australian Lysat C sections. If you click on that, that will allow you to download this folder. What you need to do is just open this folder, copy these two sections here, these two files please, the RFA, the family, and the text file. Select import and copy, Ctrl C, and we go back to Revit, load family, and just paste them here within the light gauge steel. Please make sure you are under Australia structural framing light gauge steel. Paste. And now we've got the Australian Lysat C sections. If we open those, we've got the full selection of C sections we use here in Australia. If we look at our specification for this model, we are planning on using for Purlins C 219, so it's 200mm deep section, 1.9 thick for the steel, and it will be spaced at 1200 centers. That's for the purlins. For the girts, we'll use the same sections but spaced at 900 centers. Okay, knowing this, so we need to load the C219. Now we have this section into our model. Now the second thing is to start inserting the beam system. Inserting the beam system, one of the main steps that you have to do, you have to set a plane. You have to set the plane where the beam system will be sitting within. In other words, for our purlins, we have to have a plane going within the roof to allow the beam system or the purlins to go in that plane. Now the problem with choosing the top of the rafter, if I will exit from here, I'll see the plane that I currently have. As you can see, we choose the top of the rafter here as a plane. Usually this plane not perpendicular to our grid system. So it's not in line with the X and Y for our grid system. That will create lots of issues for us for the beam system. Therefore, we won't be able to use the top of the rafter as our plane, although in theory it's correct. That's where we want our purlins to go. But anyway, this is not a very long process to overcome or an issue to overcome. What we'll need to do, we need to create a temporary roof in theory, and a dummy roof, call it if you like. This roof we'll use as a plane only, and after we finish with that roof we can either delete it or hide it. So to create a quick way to create a roof, we can go to architecture. If I go to the west elevation, one of the short elevations, we can create a roof by extrusion, what we call it. Roof by extrusion is asking me for the level. We can use the apex as our level, doesn't matter for now. And quickly I can select the lines where I want my roof to go. I can select the top of this rafter, top of that rafter, and then be careful, you have to join these two lines using the trim tool just to make sure that your roof is continuous, otherwise the system will give you a message to join these two lines. So now we created where the roof is going to be, or on what line. You will see in a second how this roof will be created by extrusion. If I go OK, the roof we chose was just a basic generic roof, 400 millimeters. Let's just use a thinner one. I've got the 125 here, that should do the job. It's not very important to us at this point where the roof is sitting, what height, what thickness. As we said, this is a temporary measure that we are using just so we can create a plane. Now let's look at the roof in 3D. If you can't see the roof here, simply because our visibility for the graphics doesn't show the roof. So if I press VV and I tick the roofs, now I'll be able to see this roof. So the roof is not sitting in the right location. That's fine, we can adjust that easily. We can look at it from the top, slide the roof where we want it to go. So from the edge here to the edge of the rafter here. It's good. Now looking at the roof from here, because we've got the roof now sitting within the framing members and within the rafters and all of those, just easier, and you see down the track why, if we can keep those separated. So if I move the roof upward by say 500 millimeters, so if I look at it just from the edge here and move the roof, keep the constraint on and move 500 millimeters up. That way I'll separate the roof from everything underneath, because as we said, we want this roof just as a plane for us, as a guidance, that's all. That will do. Another thing you can do, just make this roof transparent by just right click on it, or right click on it and change override graphics in view, or from here you can just simply override graphic by elements, and we can change the transparency on this roof to 80%, for example. That will make our roof transparent, that we can see through it, just easier, so we can see the other structure underneath. Okay, so the entire thing here we've done just so that we can use it as a guide for our plane. So if we go back now to our step beam system, and the first thing we do, we select our plane, pick a plane. I'll choose either the top or the bottom plane of this roof, one of these roofs, like either this or that one. So let's start with this one here. So I'll choose the top, it's easier. Just be careful please when you're selecting your plane, make sure that you are selecting the right plane. As you can see, I'm selecting the top of the roof now. It could be very easy to make a mistake if you put the mouse here, you'll be selecting the side of the roof. Just keep an eye please on what plane you are selecting. So obviously now I'm selecting the top of the roof. I've selected my plane. Now to choose the boundary, and this is the reason I moved the roof by 500 millimeters up. So I can just have these clear lines here, because to select the boundary, I either can draw the boundaries, look at it from the top here and start drawing my boundaries, or easier, I can just simply pick these lines that will create this boundary. So I either can start picking each one of these lines separately, or even easier, I can just again do this hover over this top plane, press tab until I get the top plane. By clicking on it, that selected the boundaries of the top plane quickly. Okay, and for the direction, you can see the direction is already established here. It's showing the purlins will go in that direction parallel to this edge here. If the system chose the wrong direction for you, you can always choose the direction that you would like. In this instant, we want the direction to go by these two lines. So either of these two long edges will do the job. I'll just go back to the boundary lines. In case that you couldn't pick the top plane, you can select each one of these planes separately. So if each one of these lines or edges separately. So if I just delete these edges that I've selected already, go delete. To select the boundaries, I can either select these lines, each one separately. Just be careful when you select those. So I'm selecting a plane here, I don't want that. Tap, this is the edge. And this one here, tab again, and this is the other edge. So all methods will work. It's just they're quicker. You can do it the better, as usual. So the first method is the quickest one, and the slowest one, if you would like, you can just look at it from the top and just draw your boundary. Very simple. Just choose a rectangle and draw your boundary. So we selected our boundary, selected our direction. We can go OK. Before I went OK, we could have just adjusted this beam system specification from here, but if you forgot, that's not a problem. You can just select this dashed plane or the group of dashed lines that will select your beam system. If you couldn't select that, just please, if you are here, just press tab, hover over it where you're expecting your plane to be, and that will give you the option to select that beam system. So we want our beam system to have a fixed distance of 1200 as we agreed for the roof, and I would like this to start from the direction line. So we chose the direction line, this, so we can keep everything consistent with the other roofs that we're going to create. Let's double check our direction line. Always let's choose our direction line, the outer edge, and I'll use that my 0 for the spacing. So that would be 0, 1200, 2400, and as we go. So we've got that. Now to make sure that we chose the right sections too, we can go, that's already chose the Australian Lights at Sea sections 219, perfect. Let's go check these purlins, how they set. That's the part where we said that we're going to adjust our height, so it's not important to us where the roof is sitting. The most important thing that we got the right plane, as you can see. Let's check our height. So if I go to be able to move those upward or downward, it's better to work with one of the elevations, a 2D plane. So if I look at the beam system, I'm not going to select, please be careful, there's a difference between selecting one of the purlins or selecting the entire beam system. If you can see the dashed line here is the beam system. So let's select the entire beam system. Before I select it, let's see how much do we want this to move down. Obviously we need to move these purlins down. So if I will measure that distance from the bottom of the purlin here to the top of the rafter, we currently have 295 millimeters, as we learned during the class. And if you forgot, let's just remember that always we want the purlin to have 10 millimeter clearance underneath. So if we look at these Purlins Connections, paste on the file that you already have, and I'll upload this file, by the way, to the same page here. I'll add this file in here under the beam systems. As you can see, these purlins and girts, they usually have a gap underneath, and that's usually 10 millimeters. Okay, for the 200 millimeter purlins, we will have a gap of 10 millimeters. So we go again, 295 we got here, take 10 millimeters, that means I need to move it down by 285. So I'll select the entire beam system and move down 285. So we'll check that won't be, because we are moving vertically to 85 instead of perpendicular to the rafter, this could be slightly wrong, but we can double check. Still need to move 1 millimeter. So I'll select the beam system. As we said, guys, the beam system is a dashed line simply just sitting here. If you just hover the mouse between the two purlins, you'll be able to pick that, and we can select that from there and move it down by 1 millimeter. So let's check our spacing. Like that. That's good enough. That's what we're after. I can select now the entire beam system and mirror that to the other side. Okay, we agreed during the class that the maximum length of these purlins would be about 19 meters based on different criteria that we looked into for transport, for manufacturing, for handling on site. Therefore, we agreed that we are going to break our purlins somewhere here in the middle. So if I select this beam system now, let's change this to wireframe. If I select this beam system and edit the boundaries, look at it from the top, I can just simply move this to the center of this. That's what we want it to be, in the center of this rafter here. That will create a set of purlins, will be all one continuous purlin for this part, and then we'll create the other two there. And we'll press OK, and we'll do the same for that one. As you can see, I'm trying to select the beam system just by clicking once on tab. That selected my beam system here, edit boundary, and move that to here. And that's the center of that. Now these purlins, as we agreed, they should be away from each other 10 millimeters. So I'll move it 5 millimeters that way. I'm in the center here. I'll select move it 5 millimeters this way, and that will create that with another 5 millimeter on the other side. That will create a gap of 10 millimeter between these purlins. I want these purlins to extend 200 millimeters to the outside on this side here. So I can just simply select that and go to move 200 millimeters and pressing OK. I have to close these edges. I'll go back to continue and trim and extend these edges here, and that's done. I'll just do the same changes for this beam system here. Edit section, edit sketch, move this one 5 millimeters that way, and move this one here 200 millimeters. Make sure the edges are closed and press OK. Let's look at it. That's what we are after. Now if I go to the AVIX view, I can select these beam systems by tab and right click, select all instances that selected the two beam systems at the same time. I can mirror them now both to this center line here, and that created my beam systems for the roof. Let's look at it in 3D, and that's how we got our purlins done. Okay, so let's try to understand what we've got there so far. To start with, the thing that you need to know, when we chose these two beam systems to start from, first of all, the roof here is not needed anymore. So if I just go back to shaded view, all this roof, we can just hedge, that will hide it. We don't need it for now. If down the track we determine that we don't need it anymore, we can delete this. First of all, as you can see, the beam system starts here from the edge of the roof, which is exactly where we want it to start. Having said that, that beam system drawn the first purlin at 1200 centers. That's the setting on the beam systems. We'll start drawing the first beam at the given distance, which is 1200 in our case. Therefore, we need to add one purlin manually here. The beam system is good enough here, close to the edges, and we need to add another purlin, if you remember, outside the column, so we can support the roof on the outside. That's the reason we created this small roof rafter here on the outside, so we can support that purlin there. So if I just go to the west elevation, for example, one of the short elevations, so I can see these purlins clearly. As you can see, you can still see the roof here. There's a chance we don't need this roof anymore. That's good to note. We've got our purlins are not in the same direction, so we have to fix that to start with. So I'll just make them all facing up, for example, facing the ridge. So if I select these purlins here, or in fact if I select this beam system, which is the closer one to us, I'll just change I have to select them one by one. The one are facing downward. This is the issues comes from mirroring things. Maybe we could have avoided this. Let's try this. We could have avoided this just by copying rather than mirroring. Okay, let's try to do that. So if I go back to the ABX view, this is the second beam system that we added here, and the other one we have here. First we'll delete that. So for this beam system now, what we can do, we can copy it. From the edge of the purlins, select the beam system, copy this. I'll choose from the edge of this purlin here, copy it, keep the constraint on, and all the way to the edge of, or the center line of this rafter. I'll select the beam system again. I need to offset it by 5 millimeters. This is the beam system, and move it by 5. As you can see, that will create the same overhang on this side, which is 200 millimeters. So I'll do the same for this beam system now, by simply, I'll do it again, select this beam system from here, go copy, choose my paste point, the edge of this purlin, to go to the center line of this rafter, and then move the entire thing by 5 millimeters. Let's look at it in 3D. That looks good, and from the elevation, even better. Okay, so in terms of direction of the purlins, not very important to change this direction of the purlins, but what you could have done, if you would like, you could have just select these purlins here. I'll go filter, uncheck all on the joists only, which is the purlins. And we can just simply rotate those by 180 degrees. That will change the height of those, not a problem. We can just simply, rather than the justification from the top, if we choose the bottom, that will fix it. Okay, so now we've got them all facing the apex, and they all sit at 10 millimeter of the rafter. Okay, so we go back to our point. We were saying that we need to add one extra purlin here, another extra purlin at this location here. It's just simply all what we have to do, select these two purlins. When I'm saying these two purlins, there's one here and there's one behind it, because we said for the entire warehouse we will use 2 lengths of these purlins. So by selecting this section here, altogether we'll be selecting 2 purlins behind each other, and I can copy this one. As you can see, it's just moving in the direction of the rafter, and we can move it to sit somewhere here. We'll keep it away from the connection to allow for, you know, the tightening of these bolts and the rest of it. So let's move it 1000 millimeters, so a meter, which is acceptable because the maximum distance we have or spacing between our purlins should be 1200. Anything less would be okay. And then let's copy it again to sit somewhere here, and that distance is about, say, 850 millimeters, or let's make it 870 again. I'm trying to make it as far as possible. away from this column here, the face of the column. Okay, so we've got that done for the purlins, and we'll do the same thing on here. So I can select these two here, copy 1000, and then copy this one here, 87. Done. That way, if you look at it in 3D, we've got all our purlins for the roof, and that's covering the entire roof. As we agreed, guys, that adding this additional rafter here will support the last purlin, and that will make us avoid any support to go on top of the column. So the roof sheets, in theory, the roof sheet will go where that dashed line is. We'll go all the way above these purlins, all the way to the last purlin here. Okay. So that's the purlins done. Now the girts for the walls will be much easier, because simply you don't have to set a plane or create a plane for the wall. You can simply use the top face of, or the outer face of the columns as your plane. So if I choose that, simply quickly I can create those, and you can see me working on them. Beam systems, set my plane, or pick the plane to be the outer face of the column. My boundaries, let's look at it from the side. I want this to go from somewhere here, just underneath this rafter, just all the way here, and maybe 200 to the outside, but we'll worry about that later on. So somewhere here all the way down to the floor line, or the floor level, and in line with this face of the column. So what I can do now, simply adjusting these boundaries. As we agreed, these will have to go 200 millimeters to the outside. So if I press escape, select this one here and move it 200 millimeters to the outside, and move that 200 millimeters to the outside. Make sure, very important to make sure, please, these lines here sits the bottom line sits with the finished floor level, and the top is not very critical for us. Trim and connect everything together. Make sure the corners are enclosed. Set our direction, that's the direction that we would like, and we are good to go. Simply we have to change our spacing to 1000 millimeters. We agreed for the walls, and that's the right section. As we agreed, that will be measured from the direction line. And let's use the floor level is our first starting point, which is the direction line. Okay, let's make sure that this line here is your direction line, because that's how the spacing will be measured for these girts. Let's go okay. And you'll see the benefits of this in a second, using one datum for your directions, for your spacing of these girts, because we want the girts on all walls to line up. Okay, so we got that done here. Again, I forgot that we need to break this into two components, and two beam systems rather than one for the entire wall. So what we can do, edit boundary, I can move this here from this point all the way to, just looking at it in wireframe, move this somewhere here to the center of this column. Now we'll move it again 5 millimeters that way, and trim and connect. What we need to do now, just simply copy this all the way here, the center line of the column, and then move it by 5 millimeters. that will make it extend all the way to the outside. Okay, so that will set our, let's make sure where those are sitting, because from the graphics it shows that they are sitting between the columns. That's not what we want. We want them to sit on the outside of the column. So if I look at it from the side elevation, which is the west elevation here, I can see those sitting here. What we need to do is just measure how much we need to move them to the outside. So from the base of this girt to the face of the column, I've got 2 or 3. I need to move another 10mm out. So if I select this beam system, I've got the beam system selected here. As you can see, the dashed line, select that and move it 213mm to the outside. I still have the other one behind it. Tab. Let's look at it in 3D so we can select that. This is the one still sitting within the columns. Selecting that, going back to the west elevation and move it 213mm to the outside. Okay, I don't see an issue for copying, for mirroring those to the other side. We can just simply mirror. That shouldn't create an issue about the rotation. All what we've got now, simply just to rotate those downward to be similar to those girts here. All what we have to do, just selecting all these girts here. Yep, that's it, that's the last one. We can select all of those girts and simply filter our selection to framing, the joists, okay, and then we can just rotate those by 180 degrees, and we change that to justification from the bottom, apply, and that did the job for us. Okay, they're sitting on the face, right on the column, 10mm outside the column, a gap, and they're all facing down. Now, as you can see, similar to the purlins, we need to add another girt somewhere here. Obviously, there's no girt, we've got 0, so let's keep it at least 200mm from the floor level. And we need to add another additional girt somewhere here, so we can support the wall sheets there. So if I select this girts here, and these 2 here, got to press Control, these 2 on both sides, and I can copy these to the top side. Let's say we copy them about 900mm, and we can adjust the rotations on those to be 180. Sorry, it should be 90. Just try that. So let's look at that one there. Yep, both of them will be -90, and that will do the job. Okay, for both of them. I can copy those, what we just created now at the top, because I've got all the right settings on them, somewhere just here, and then we can adjust the height of that as we go further. So we agreed about 200mm. Just say projects. So let's measure where this is sitting from the, that's 332, so we need it to be 132mm down. This one here, that one there, again I forgot to press Control, and we move them down by 132. That will be 200mm from the floor level. That will allow enough clearance for this girt from the ground. Okay, so we finished our girts and purlins for the long wall and the roof. Now the only one part we still have to do is the short walls here. Similar to what we've done before, we're going to choose our plane, steel, structure, beam system, set the plane, pick a plane. I'll choose this thin edge of the corner column as my reference, because that's where we want the girts to go. we want the girts to be just on this, a little bit away from this face. Okay, 10 millimeters as we usually choose, 10 millimeter gap. So if I look at this corner column here, if I go back to the apex view, on this corner here, I've got this column. I want the girts on this face of the wall just to be off this edge of the columns. The reason I'm choosing this, not these columns, because I'm a bit suspicious that if these columns, as I can see here, the columns here not sitting in the right plane. I'll double check that in a second. I'll fix them just to make sure that all the columns they're sitting within the same line for the girts to go on. So let's start with, let's go back to here, choose our plane for the girts to go on, and that'll be this face of the edge of the corner column, the edge of the flange for the corner column. So we set our plane, and now we can simply draw the boundaries. To draw the boundaries, I'll look at it from the side here, and it's easier to pick lines from here. I'll just choose this line here, the floor level, and I can just the outer face, and I'll just draw line here, pick this line here, this line there. It's not very critical for us now. That's where we want them. So let's fix these lines. If I press escape, I want this line to set 200 millimeters to the outside as we agreed. And we want this line, the same thing, to set 200 millimeters to the outside. It's more than 200, about 203 or something, but that's not an issue. You see it in a second, we can fix it. Now for these two lines, I'll move them down so it doesn't interfere with all these connections here on the, we don't want any girts to go at this area. We've got lots of connections and we've got enough frames to connect to. So I'll move these lines, these two lines down a little bit, say 300 millimeters. And simply all I have to do now is just close all these lines together. Okay, so now we created our overall frame where we want those girts to go. If I press OK, first of all, let's fix those to be 1000, the right, and from the direction line. Perfect, that's all the settings for us. So if I go from here and press OK, we found that we will find that we have a problem there, or a mistake, or not a big problem, but something has to be changed, which is, to start with, we've got our girts are blocking the openings. So that shouldn't go there. Secondly, we have to readjust the location of these girts set properly. That's fine, we can do it, shouldn't be a problem. But the first thing, we have to clear these openings. So I've got these two smaller openings I've got here, the 4 meters by 4 meters doors. So if I go back and just select my beam system, hover over this and one click on tab, that will select the beam system, edit boundary. All I have to do is simply, guys, just I have to draw boundaries here on the openings, okay? And that could be done quickly just by selecting these lines, these edge lines of the beams. If I choose that here, I'm selecting the edge of the opening, okay? What I'll do, choose that instead and delete the excess lines that we selected here. And using this split tool, I'll split this line here, you see why now in a second, and this line here. Simply what I did, this line, instead of being continuous line, now I made it into 3 different lines. The reason is so I can quickly use the trim and extend tool. So as you can see, I do have 3 lines and I need 3 lines. If I kept one line continuous, that means that will be trimmed here and I have to redraw these lines. But quickly I split them so I can create the 3 lines and then start trimming them. So now we created these boundaries. If I click OK, that will tell me you've got too many lines with directions. So let's go back and choose our direction. I'll choose just this one here and then go back to choose one line with direction. And if I press OK, that should fix the issue. Okay, we've got this openings already cleared with the girts. Now let's just double check the level of these girts. First of all, let me fix the end wall or the short walls columns. These walls here, the columns here, this column here for example, should be sitting in line with the outer edge of this column here. For some reason when I was drawing maybe the beams, I moved them. That's fine, we can easily just go to modify, align, and this is my reference, the corner of the corner column. This is the line, and I will make sure it's multiple alignments. So I'll align multiple members. So where is the first column? It shows this is the first column here, and I want the face of this column to sit in line with that. That will move the column. This is the second column. I'll move all these columns just to sit in the right location. We have to be accurate on what lines we are clicking. That fixed that side for us. And just enter. Escape. As you can see, these columns now aligned with that line. Perfect. Now let's do the other side just to make sure it's all set properly too. So I'll choose the corner here of this column. Multiple alignment is on. Be careful please and zoom in properly to the element, because you can see there's too many lines that you can click on by mistake. So make sure that you are zooming in enough to choose the edge of the column, nothing else. That's it, where the four columns are aligned now. Enter and escape. Now we've got all of that sorted. So if we go back and look at our girts on this side here, change to wireframe view. We added the girts on one of the walls, which is that wall there, and we have to move those to the outside. If I look at them from this side here, as you can see, these are the girts are sitting there. So I can just select the entire beam system and move that to the outside by 213 millimeters, 203 for the girt width, and 10 millimeter gap underneath. Let's double check that measurement. So if I measure, I can't measure here on the 3D, I have to go to the elevation. That will be the north elevation for example, and change that to wireframe, and checking which one. This is the one here. These are the girts. Checking that measurement, 10 millimeter, perfect. Now let's double check the orientation of those two. So going back to 3D from an angle, these girts are facing down, similar to the other girts there. That's exactly what we are after. Okay, so I'll do the same now for the other shorter wall. I'll go beam system, set plane, this plane. Now I can with confidence choose the face of this column here. I don't have to go to that corner there, because I set all these columns to be aligned together. I set the plane, and now to draw the boundaries, we'll look at it from the side and start drawing boundaries by picking lines. So I want this to from here. I'll just choose from here this time. Maybe I'll choose a line from here, a small line from there. It's just choosing a group of lines, and then I'll do the job by, okay, we chose that, so I'll choose this, I'll continue with that. I'll delete this extra line. Always when you have extra lines, that will create issues for you, so make sure whenever you draw a line that you don't need, you delete that. Trim and extend this small line here to connect there and there. Got that done. Again, we have to allow for the openings, so let's pick these lines too. So I'll just choose the bottom of this beam here, or the center of the beam, and the center of this beam, the face of the column, the face of the column. Done. Again, split those and trim and extend. I think everything is okay now. Only I have to fix the direction. If you look at it, if I go okay, it will tell me you've got too many lines with directions. I'll go back, just change the direction, choose the vertical, and then go back, choose the correct one. That will make just one line with direction, and that's what we are after. Go okay. It says they are not closed there. That's fair enough. We can close them. That should fix it. Okay, we got those done. Let's look at them and see. We suspect that they should be sitting all aligned in the right location. The main thing now, we have to set them to the outside, and they look like they're facing upward. I didn't pay attention to the spacing starting point. That should be direction line. Perfect, that's what we're after. Okay, so let's look at it from the side. These are the ones that we're trying to fix. So if I select their beam system from here, I can tell that's been selected because I can see the information here. All I did, I could see this dashed line, click, that selected the beam system. I can see the information here. So I need to move it the same 213 to the outside. Now we've got those facing up. We want them to face down. There's misalignment here for some reason. These are not aligned with the other girts. Let's fix them first. First of all, let's make them facing, all of those here. If I select them all, filter, uncheck all, I just want the joists. Guys, you have to pay attention that when I'm selecting this way, as you can see, I'm selecting left to right. That means this is a window selection, not a cross selection. So left to right like that, that's a window. That means everything has to be within that window to be selected. So I've selected a group of things together, but for example, these are not selected because I'm selecting left to right, not right to left. Filter, I'll uncheck all and choose the joists only. Now simply I just selected all these purlins in this direction here. Okay, so we'll do it again. Filter and joists. So what we want for those, first of all, to rotate 180 degrees per minute, and I want them to be the Z justification from the bottom rather than top. Perfect. Now they're sitting the right level and the right spacing. Okay, that's done. We've got all of those done. So if we look at it in 3D, change to shaded view, you managed to create all the purlins and the girts for the entire warehouse with the exact right specification and the spacing. Most importantly, all of them, as you can see, they line up together. We will talk about the connection details for those down the track. It's very simple as just selecting these two together and going to steel and mitre. Okay, simple as that. That's the type of connection we'll create there. So regardless of that, we'll get to it down the track. I can see here I missed on adding the last girt at the bottom for the short wall. So if I select these girts here and simply just look at it from the center, from the edge here, and I'll change that to wireframe, copy those from this line downward to this line here, and this constraint is activated. It's fine, got that distorted. In terms of direction, we can fix that. For these girts only, we'll make it -90. I think from memory that worked for us. Perfect. Okay. So if we look at them, they all have the girts, and I'll double check the other face there. Copy. And we have to change -90, and that will do the job. Perfect. Okay. So we've got all these girts, they're sitting at 200mm from the ground level. Alright guys, in our next video, start looking at the connection detail between the purlins and rafters, which is very similar to the connection details between the columns and the girts. And we'll look at the specific connection detail for the fly brace, as well as the slight different connection details where we have the split area here. Alright, thank you.